And Здравствуйте, and welcome to the talk Transforming Business with Spatial Computing and HoloLens 2. And so in the next 30-ish minutes, I'm going to tell you what is spatial computing, first of all. I will show you a lot of use cases like digital twins, and I will also give you, some business motivation, like why you should care about it, because there is a big money to make, actually. We will also talk about other cases combining AI with mixed reality, how you can do 3D scanning and even 3D live streaming of such stuff. Should be a plenty of things. My name is Rene. I'm a Director of Global Innovation at Valorem Reply, and so I work on research and innovation around emerging technologies, and our team basically does the groundwork for new research for spatial computing, which I'm going to explain what that is, computer vision AI, quantum computing, and all these kind of interesting emerging technologies, right? I'm also a Microsoft Regional Director and MVP, like my friend Andre, and we basically are community leaders in a certain space and shouted knowledge. So we go out and talk at conferences and do some fun stuff there. I'm also advisor for the VR and AR Association, as well as our friends at the XR Bootcamp. Just look at this. This is a calendar from XR Bootcamp. This is Baby Yoda wearing a HoloLens here. Alrighty, folks. So before we explain what is spatial computing, let's go back a little bit in time and look at personal computing. Personal computing really became a thing in the, let's say, beginning of the 1990s, or for some in the 80s or 70s even, when these PCs entered the home. And personal computing was for a long time the dominant computing platform, especially once they became internet connected, of course, right? And we had a lot of exchange between these personal computing devices, and the web changed everything, and content sharing was really possible across many different venues. After personal computing, mobile computing hit the space, and especially with smartphones like definitely BlackBerry, but later on even more so when the iPhone with touch input came out in 2007. That really changed the game, and most folks these days, and especially in certain countries, they never actually experience personal computing. The first endeavor with computing for them is typically mobile computing. And so after personal and mobile computing, we're now entering this age of so-called spatial computing, which means these devices are spatially aware, right? And so we have devices, for example, like the HoloLens I have here, the HoloLens 2, right? Which is this self-contained head-mounted device that you can put on your head. You would wear it like this. And as you see, it has these fancy displays here, right? Where you can see the real world, but also virtual objects. But what is really interesting are all these sensors. You see these cameras, these sensors that capture and the environment, right? Depth camera, normal cameras, and so on. And all of this does spatial reconstruction, which means this device and other devices like also Magic Leap and whatnot, they can reconstruct the environment you're currently in. They're spatially aware, which means it knows there's a wall, there's a ceiling, there's a floor, right? There's a certain environment around you. It's spatially aware. It has this spatial map. The same thing also actually applies these days on smartphones, right? So I have a smartphone here, just a normal Android smartphone, which has, of course, some good cameras, but in the end, it can also sense the world around us. It can understand, okay, what's happening around you, right? And if you see the video here, this is an example of the Microsoft Mesh platform, which I'm going to show a little bit later in more detail. But I'm showing you the video just for taking a look at the experience here, right? You have this lady wearing a HoloLens. You have this gentleman using a tablet, right? And this is what spatial computing is all about, right? You have these diverse devices, but they're all spatially aware, right? All of these are spatial computing devices. And that also includes virtual reality devices, right? Where you put a thing on your head, you don't see the outside world anymore, you're fully immersed into a virtual world. And that is also spatial computing, because this device also knows where it is in the room, right? So spatial computing is about devices that can reconstruct the environment you're currently in and provide contextual information. And all of these different devices should be able to collaborate with each other, right? And for this, they need a common reference map. They need a common understanding of the world around us. They need, if you will, a digital twin of the real world, right? And this is possible with a technology called the AR cloud, the augmented reality cloud. And I will tell in the talk later on much more in details, and will show you lots of cases for augmented reality cloud use cases and scenarios. What you see in the video is like just an example of some of the 3D reconstructions all of these devices do. Like a HoloLens does a 3D reconstruction, this mobile phone does a 3D reconstruction, all of them. They need to understand the environment, right? They need to reconstruct the environment. But it just lives on this device, or it just lives on this device, right? And the power of the AR cloud is that we can bring it together because we can merge it and securely store it in the cloud. And with this, we get this digital twin, this reference map of the real world. And I could, for example, go to a certain place, scan it a little bit with my phone, put a virtual object there, and then here in the video you see the family comes to the same spot, and then they just use their smartphone or just with their smart glasses, right? It will recognize, okay, this is the same place, someone left some virtual content there before, and well, then it can reconstruct it, right? And so this is why the spatial computing with the AR cloud is so important, because it allows us to have these kind of experiences where we can share it with each other, right? Where we can bring these collaborations together for spatial computing devices. I will show you much more, so it becomes a little bit less abstract, but let's take a look. What is the ROI? What is the business impact we're seeing? And well, it's quite dramatic if you're looking at HoloLens here in the case and Microsoft's mixed reality. You can see some big customers there, and a lot of them deployed a software called Remote Assist, which I'm going to show later on. And as you can see, they have huge cost savings, right? I mean, 40% reduction in travel costs for Mercedes-Benz is just amazing, right? And because they can now call in the remote experts, right? They don't have to travel there, which is also very hard at the moment. And so there's a lot of strong use cases for remote assistance. And again, I will show you what they're basically using with remote assistance in a few minutes. But just look at the first one of the use cases I bring here with me, which is about digital twins. And so what is the motivation? Why should you care about it? Well, if we look at Gartner, the famous market research company, they have, of course, this emerging technology hype cycle, and they also have their trend impact radar, which you can see here on the slide. And as you can see, the digital twins are pretty close to the center, so they're becoming very mature. But even more important, Gartner is rating it as a transformational platform, and they're saying like 50% of large companies will be leveraging those. And I can tell you, I live here in Dresden, in Germany, and basically what Bosch, like the large manufacturer, you might know Bosch, is actually, they just opened a new semiconductor fab here, where they will produce new like chips and so on for automotive use cases. Anyhow, why I'm telling you this is, they created a full digital twin while they were building this fab. While they were building this factory, they created a full digital twin of that factory. And so they have every little piece as a 3D model, and they have all of that as a digital twin from the beginning. Or before they actually launched the factory, they built this up, and now they can do some pretty amazing things like, you know, visualizing it, but also getting much better insights. And here's a quick demo of a similar case we built for Microsoft. This is the digital twin experience, where we use a digital twin, which is this kind of digital replica of a real world entity, right? And typically it would be a machine or a building or something like this, where you have a bunch of sensors deployed, like in the case of Bosch, for example, in their fab. They have all these sensors all over the place, and so they can, you know, kind of measure certain things, and then you can show that on top of the digital twin, and typically you would do that on a 3D model. And this is what you can see here in this kind of experience, what we built for Microsoft with the HoloLens. And so the lady there using a HoloLens, she can see a virtual model of a chemical plant right in front of her, right? So this is a chemical plant, and this chemical plant has a bunch of IoT sensors deployed all over the place, right? In the real chemical plant, you have IoT sensors, and now we have that 3D model of that chemical plant, and we can visualize these IoT sensors right where they are in that real chemical plant, right? And so this is using Azure IoT Hub. We take all these IoT sensor data, bubble them up, aggregate them in the cloud, and then stream them and show it in real time on this digital twin, basically. And here you can see also some sensor values that are currently active, like temperature, humidity, and things like that. Pretty straightforward stuff. But you can imagine if you scale it up to a huge production facility, this becomes super interesting, because you can not just see a table of all the sensor values, but you actually see it in the context of the real object. And that is super useful. Of course, mixed reality, big on training as well. And here's a second part of that, where you can see that we have this little sensor box that we show how you can repair it and so on as part of that experience. And yeah, so digital twins really gaining a lot of momentum. The other one I brought here is remote assistance, and I've shown you the kind of business highlights from a bunch of Microsoft customers like Mercedes-Benz, L'Oreal, and so on. They're all using this Dynamics 365 remote assist solution. And what it does is basically it allows you to see what a person wearing the HoloLens is currently seeing, right? So if you take a look at the photo here, the lady wearing the HoloLens with the camera in front is streaming real time into another Microsoft Teams instance where this gentleman is sitting in front of a desktop PC, and so he can see what she's seeing, first person view basically, and provide of course audio instructions like tell her, okay, you know, I don't know, open this log or whatever, and also can draw into the space, right? So the gentleman can, for example, draw little kind of arrows in here, for example, right? So he could say like, hey, draw it like this, and so this is what he can do via Teams, right? This is what he is able to do from his desktop Teams instance, which is super useful. Also works on mobile, but even better on the HoloLens, because as you can see, when you wear the HoloLens, right, you have displays right in front for the left and the right eye. So you see the real world plus these virtual objects in stereo 3D in front of you, plus you have your hands free. Right? The HoloLens 2 is a Windows 10 device you wear on your head, no cable needed, fully self-contained, and hands-free for real-world tools, right? Which if you use this remote assist on a mobile phone, well, you have to hold the mobile phone, right? You just see it on a tiny screen. And so the HoloLens experience is, of course, much better there. Another interesting new solution is coming from Microsoft is Mesh, Microsoft Mesh, and it's kind of a solution for immersive workspaces, right? Where we can build these collaborative work environments for teams that are actually geographically separated, right? But they can be working together in an immersive fashion. And yeah, you know, Microsoft Mesh is not an end-to-end product, so it's not a final product you can buy. It's rather a platform developers can use to build custom solutions on top of. It's kind of a middleware, if you will, right? And it provides you a bunch of really interesting things. And first of all, it's a multi-platform. So it will not just run on the HoloLens 2, it will also work on the Oculus Quest, it will work on mobile phone, iOS, Android, tablets, Windows PCs, and even Mac computers. At the moment, of course, very, very early, and they just launched a demo application for the HoloLens 2. So if you have a HoloLens 2, you can actually already try out Microsoft Mesh with this demo application. And that's what I did here, which you can see in the video with a colleague of mine who works in the US. He lives on the West Coast in Portland, Oregon, or actually not in Portland, but in Oregon. Anyhow, this is 9 hours time zone away from me in Germany. And we both, you know, collaborated together in Mesh. And what Mesh provides us as developers is the base building blocks. So what it can do, it can, for example, handle the multi-user sync, right? That if I do some interaction on my side, the other gentleman needs to see it on his side, right? And so this needs to be very short in latency, and so not a long delay. And look at the high five here, right? And the video, there should be a high five. Look at this. Like, this is just perfect, right? There's no delay, really. And we're talking 9 hours time zones difference, and that is working really well. And this is what Microsoft Mesh solves for us, so we as developers don't have to care about it, right? They will also bring this kind of presence in, like this avatar system, or later on even 3D video, and, multi-platform collaboration solution we can build on top of. And it's pretty fantastic, and we're excited to build some solutions on top of that. Cool. So, well, I told you, Mesh is really interesting for a bunch of things, but, you can also do other things. You can even do real-time AI on the HoloLens because it can recognize real-time virtual objects or real objects, right? Real-time object recognition there. There we go.
This might be a car wheel 3.5 meter in front of you.
Okay, so here you can see an experience.
This might be a matchstick 1.1 meter in front of you.
Let me quickly switch back to the mouse.
This is likely a minibus 3.1 meter in front of you.
All right, so let's turn off the audio.
Volkswagen multivan generation.
Anyhow, so what do you see here in the video? This is recorded while I was wearing the HoloLens, and what it does object recognition, right? And so it can recognize what you're seeing in front of you while wearing the HoloLens, and it will use text-to-speech to output that. And this is, of course, using an AI model and basically custom trained for detection custom objects. And you might wonder, why would I need that? Well, think about special tools, right? Not just a power drill, not just a hammer, but special tools you want to use in your work, and you put on the HoloLens, it will tell you what it is and how you can use it. And you can even bring a beer here, and it will tell you what kind of beer brand it is.
Burger beer bottle 1.2 meter in front of you.
Well, a little bit too early to open a beer, I guess, but maybe later on. But anyhow, you get the idea, right? We can run real-time object detection on such a device, which is pretty fantastic, if you will, because you know you don't need a cloud connectivity. It does all the detection on the device, which is pretty amazing. And well, we talked about spatial computing devices with the HoloLens, mobile phones. I also said virtual reality headsets. And guess what? This is not just for humans. Like, look at this. This is actually a photo from 2019 from, if you look closely here, it's from the Ministry of Agriculture and Food of the Moscow region. So this is actually from the Moscow region, and dairy farmers are exploring how they can use 360 video for, you know, these animals, for cows, to providing them a better life experience, I guess, and, you know, getting higher, reduced stress and anxiety, right? And maybe show them like a green grass field instead of this you know, place they're currently in. But anyhow, just found it funny here that VR is not just for humans. Okay, large-scale digital twins. What is that? Remote rendering is the topic here I want to quickly cover. And there's a service called Azure Remote Rendering available. Also, other players are working in the field like NVIDIA with CloudXR or Google and a few more. And basically what this cloud rendering or remote rendering is doing, it allows you to 3D render very, very complex 3D objects, like this car engine here, for example, which has 19 million polygons. If you don't know what a polygon is, doesn't matter, but just consider on this mobile or standalone device, the HoloLens, you can render around 100, 200, 300,000 polygons, maybe up to 1 million polygons on the HoloLens directly, but never you would be able to render 19 million polygons on the device. And this is where remote rendering comes into play, where it helps to basically render these super complex models in the cloud and then stream the rendered content into the device, right? And for this, you of course need a very short latency, very good connection, like 4G, 5G is very interesting in this case. But it's a super interesting and very, very essential topic for the future. Because, you know, devices like the HoloLens, they're not huge, but this is not something you can wear the whole day, right? This will be glasses like this. This is what we want in the end, this kind of a size, right? And in order to accomplish this, what remote rendering will be an essential technology for this, because we can offload some of the heavy lifting into the cloud, right? Some of the heavy processing can be offloaded into the cloud, and so you can combine this intelligent cloud, intelligent edge, and, you know, take advantage of both things basically by, you know, being able to render these super complex models. And you can basically take computer-aided designs, CAD designs as they are. You don't need to reduce them. You can show them in the full detail, and that is fantastic. And it will also allow us to have smaller devices, because you don't need to have a big graphics card on the top of your head, right? But you can offload that into the cloud. And thanks to great connectivity that is there, it actually works. Another Azure Microsoft service, or Azure Mixed Reality service, is Azure Spatial Anchors, and that is an implementation of the AR cloud that I introduced earlier, right? This kind of digital twin of the real world. And again, Gartner is also labeling the AR cloud as a transformational technology, which is on Gartner's scale the highest benefit rating they give. It's still early, but basically they're saying this will completely change how we interact with the world around us and, you know, how companies work there. And how does it work? Well, this is one example how you can basically construct this digital twin, this AR cloud. And what you see here are these gentlemen walking around with their smartphones, right? And here you see these smartphones capturing all a little portion of that office, right? Everyone is creating a little puzzle piece. And the power of the AR cloud is this, where we bring these puzzle pieces together and have this kind of 3D reconstruction of the whole office, right? From all these different devices, unified and merged. And what we get with this is this kind of reference map. This, you know, reference map, this digital twin of this environment, which we can then use with computer vision to put virtual objects all over the place, right? And one use case is, for example, this here, where we created an application with Azure Spatial Anchors for mobile. And so what you see here is this gentleman using his Android phone to scan the place a little bit, right? So you see here scanning the place, and then he's creating such an anchor point. And take a look at the lady there. She's using her iPhone and scanning the same spot, right? But she's standing on two opposite sides of the views, right? But both, thanks to computer vision and Azure Spatial Anchors, both devices, iOS and Android, can both see the same anchor point, right? This spatial anchor point, which is kind of a reference point, if you will, in the real world. And so both are now sharing the same point, which means they can both also see the same 3D model at the same time at a 1-to-1 scale in augmented reality. And you see they can also real-time interact with it. And so this technology allows me to share devices to share content across devices in augmented reality, because I have these reference AR cloud map, if you will, with these spatial anchors, with these cloud anchors, and I can share it across devices, and I can share it over time. So I can persist these anchors, I can save these anchors, I can save these reference positions in the real world. And of course, that is super relevant here. And if you take a look at this video, this is in front of my house where I just scanned the place a little bit. And you saw it quickly found the anchor I placed there before, loaded that 3D model I attached to it, and well, shows you that 3D model right in front there attached to the anchor point, right? And that is exciting, because with this Azure Spatial Anchor technology or Google Cloud Anchors and a few other players that are entering this AR cloud space, you are able to basically take these anchor points, which are reference point in the real world, then use whatever device. Android works, ARKit on iOS works, and HoloLens 2 and 1 and 2 works as well. They can all see the same stuff together. They can all share it, and you can even save it as long as you want, right? And if you take a look here at this Easter bunny, you recorded a video around Easter here, you see it's a 3D scan, in fact, right? So it's a 3D scan of that real world object, and you might wonder, how did I create that 3D scan? Well, with this device here, right? I just basically used my mobile phone, and this is the time and age where we have mobile phones that have depth cameras, time of flight or LiDAR cameras, like they call it for the iPhone Pro. These devices with these depth data, similar like an Azure Connect, can measure the distance to objects and therefore can do 3D scanning. And that is super cool, because we can quickly create basically 3D content, which is always tough, right? You always need a 3D artist, a modeler that creates these data. But with this technology, we have mobile phone scanners in our pockets and can do some pretty fancy things with that, and can create 3D models that are really, really nice and sophisticated 3D models there, right? So that is some fun stuff. What you could also do with this technology is, of course, basically providing anchoring content in the real world with devices like different devices. So that could be like HoloLens 1, 2, ARKit, ARCore. I guess Magic Leap might be coming at some point, but all of them can share the same content together. And let me show you another case. For example, I mentioned this digital twin enterprise case before, right? And so what you could, for example, also do is you could basically put virtual panels, virtual dashboards in the real world, right? So think about this factory use case I mentioned before, right? And typically in these factories, they have all these sensors already, but they just show the sensor data in the control room on a dashboard, but typically not at the side where the sensor is. They typically don't have a display, they're headless. And so why not actually put a virtual dashboard there, right? We can put a virtual panel, a virtual dashboard where you can see the real-time IoT data, and you don't have to put a real display there. And then you can use a spatial anchor to put this anchor there, attach this dashboard to the anchor, and then everyone can, use their mobile phone or a HoloLens to, just scan the space a little bit. It will reconstruct, and then it will show you basically the information that is right in front of you. Here's another interesting case, I think, that I'm currently experimenting with. It's more of a consumer use case, but just at the end, I wanted to show you some other interesting stuff, I think. And so what I'm working on is this kind of AR, augmented reality, historic portals, or time machine portals, if you will. So what I did is I went to the public library here, university library, and they basically digitalized some old video content before World War II. And what I did is I took some of that and extracted short clips out of this. and basically put them at the real world location here in Dresden. I live in Dresden in Germany, right? So it was quite heavily bombed in World War II. And so there's a lot of changes between now and back then, right? And with this, I get these kind of historic portals that I actually attach at the real world location to a spatial anchor, right? And so with this, you get this kind of time machine portal back into the old days and can compare how it was looking there. For example, if you look at the two church towers there, this was, for example, not rebuilt after the bombing. So, it looks quite different these days. And that is, of course, really interesting. And again, you basically can also run this through some AI pipeline to, enhance the experience here to provide a better full colorization, 60 frames per second, 4K resolution, all of that done by taking that old footage, running it through an AI pipeline, and then you get this really fancy visuals, right? Not related to Azure Spatial Anchors from the AI pipeline, what you can do with the video clips, but Azure Spatial Anchors is used here, the AR Cloud, to attach these virtual clips to the real world location, right? So you don't need to print a QR code. You don't need any augmented reality marker or anything like this. The real world becomes your marker, right? And you can, for example, build a tourist attraction experience here where you could go through the city and just hold up your phone, right? Just like what you see here in the video, this is recorded on my Android phone. And so you can, like I said, share it with multiple different devices and basically use them all over the place. Another interesting case is with these anchor points is they don't have to be visual, right? I just mentioned you can put these anchor points, at certain places, and you can even connect them with each other. Like I put an anchor here, I put an anchor there, you connect them with each other. And so you could build navigation solutions, wayfinding basically. And this spatial map, what it is in the end with the AR Cloud, can also be shared with other devices, like, for example, here the Boston Dynamics Spot robot that we're also working with. And this is nice because the Boston Dynamics Spot robot builds its own spatial map, right? Own understanding around the world, which you can see on the video. And if you can combine that with Azure Spatial Anchors, which is now possible, you can see the gentleman using a HoloLens, he can put like anchor points all over the place with his HoloLens or with his mobile phone, put anchor points, and then the Spot robot will see them basically and, use the same direction to walk those along and, build some really fancy things. And you could even, attach some metadata, for example, say, hey, look at this side, look at that side, take a photo, whatever it could be, right? And that is definitely some interesting stuff here. I could show you much more, but for the sake of time, getting to the end here and wrapping up real quick, I think it's an amazing time to, basically being alive and seeing a lot of interesting things happening at the moment. It's of course not just COVID, right? But it's also the age of spatial computing. And we will see many more devices that are coming out that will enable us to see the world differently, but also, collaborate together with devices like a HoloLens, but also your mobile phone. And thanks to the spatial computing and the AR cloud, the spatial web, in the end, you will be able to connect with each other and being able to experience the world in a different way. And I think it's an amazing time to experience that. If you have any questions, I think we're out of time here for doing live Q&A, but I will wait for a few more minutes. Feel free to ask. Also put my email here, my Twitter handle. Also feel free to find me on LinkedIn with my name. I constantly keep on sharing that kind of stuff all on the social media. Thank you so much and have a great rest of the day.
Thank you, Rene. I would try to pass some questions if you have some. Есть какие-то вопросы, Рене, которые я бы транслировал? Кто-то что хочет спросить, пока он с нами? Rene, the question is about is the people on the market able to use HoloLens 1 for all these amazing things that you showcased today?
The Azure Spatial Anchors works on HoloLens 1 as well. And that is possible. Azure Remote Rendering is just PC and HoloLens 2 because they use some clever tricks there. Azure Remote Rendering is the one where you can render these huge 3D models with millions of polygons. That only works on HoloLens 2. But Azure Spatial Anchors, HoloLens 1, Android, ARKit on iOS, and HoloLens 1 and 2, Android and iOS. Yep.
Rene, the question is about how the technology like HoloLens and others could be used for accessibility issues for disabled people and other options of like making people's life better.
I love that you say that because, in fact, I skipped one slide because I wanted to finish here in the time you gave me because, I'm always trying, being German, we always try to be on time. But look at this case. Can you see my screen again?
Yes.
Yes, take a look at this one. This is using Azure Spatial Anchors for an accessibility case.
Navigate to my next meeting.
Your next meeting is with Julie.
So you see the blind lady there, right? So she's in a lobby basically using a mobile phone application called Seeing AI that is also leveraging Azure Spatial Anchors. And of course, she cannot see any visuals, right? But she can still use Azure Spatial Anchors because you can attach audio snippets to it, so-called spatial sound, right? And what you hear here, look at this. So we see these yellow dots, right? But she can hear them. And while she's wearing a stereo headset, like she can hear like a beep sound, beep. And, and since it's spatial sound, okay, sound is coming from here. I need to go in this direction, right? And so this is fantastic. And this will enable actually a lot of use cases, I think, with, building a better, diverse and inclusive world in the end with this kind of technology. But also other things, I just wrote an article I can share later on about multi-experiences and, also spatial computing with a focus on accessibility. There is still a long road ahead of us for, providing true and great accessibility, especially in spatial computing. But it's a great new input modality that, with all these sensor data, basically, you have these visuals, you have these eyes basically on your head, right? You can, of course, enable much more inclusive and accessibility use cases.
Thank you, Rene. Оказалось, что у Рене есть дополнительные слайды, вот, и мы их посмотрели. Rene,
Спасибо
it was a great honor to have you here in place on our event. See you next time.
Hopefully in person, people. I would love to visit Moscow and any other places in Russia. But thank you so much. Have a great rest of the conference and
Thanks,
see you
Rene.
soon. Bye-bye.
Никита?